Huh?
Feeling okay, Uma? You're on time for class.
That wasn't funny.
Danos, thank you for brushing your hair for me. All right. Okay, so what I need right now is I need you guys to go online and take your quiz. Okay. So I'm going to pause the recording for my international students. The quiz is 8 minutes. Okay. It's 4 multiple choice questions. It is on portal, so you guys can go ahead and take it. My ET students, you're more than welcome to leave and come back as soon as you're done. Okay. It is 8 minutes. Good luck. Multiple choice, 4 questions. Good luck. I'm not going to go over the answers. Obviously, let me wait until the international students take it, and then we'll go from there. Sound good? Okay, so what I want everyone to do right now, open up Eclipse. I don't want to waste too much time because what we're going to be doing today is we're going over, like I said, today's like we're starting to do the tidbits. Okay, I want you guys to open up a new project, new class, call it DeMorgans, DeMorgans.
How do you spell it again?
DE, so DE, capital D-E, capital M, like Morgans, DeMorgans.
DeMorgan. Okay. Thank you.
Of course. Okay, can you guys see my Eclipse? Okay. Okay, so your grades are in portal already. Okay. All right, so let's talk about DeMorgans Law. Okay. So DeMorgans Law is basically, it's like a reversal, not a reversal, but it's almost like an equivalency. Okay. So as we have nots, or basically imagine it this way, we have the not operator. Okay. Now, what if the not operator is applied to something in parentheses? Okay. Does that make sense? So what if it's applied to something in parentheses? Not really a there's not really a distributive property, okay? But there is an equivalency to it. So let's get started with that, okay? So let's start off just talking about like standard Boolean equations, okay? Let me move you guys out. Okay, so let's talk about, oh, come on, why did it do that? Sorry, I'm trying to move you guys out of my way. All right, there we go. Okay, so standard Boolean equations, all right? So I'm gonna put these in print statements just so you can see, okay? So, can you guys all see okay? Yes or no? Or should I increase it? That better? Thumbs up? Okay. Now, let's say that you have this equation, not, okay? Let's say, for example, let's also just do this, okay? Boolean A equals true, B equals true, just for right now, okay? So we have A and B, okay? Let's say that I say not A and B, okay? Not A and B. The output I'm not really worried about, okay? Not really worried too much about the output. What I'm worried about is, what if I told you guys to write this the right way, like to break this down and write this out, like the way that the distributive property would be applied, okay? That is what I'm worried about in this instance, okay? So what we have is what we need to do is we need to find the equivalency, okay? And the equivalency is not too difficult, okay? As you know, the not operator basically flip-flops things, correct? Okay, so right off the bat, what would you think flips that stands out the most, just logically, and logically? Alex, what do you think stands out?
Well, the A and B are going to flip.
Wrong. before that?
The whole thing.
The and. Okay. The and is going to flip to an or. So EQ is going to stand for equivalency. Okay. So another way, or the equivalent way to write this equation through the distributive property would be not A or not B. Okay. Not A or not B. Okay. And again, not really worried about what A and B is, because if you A and B are false and you don't know how to break this through, or you don't know how to break this down, you're not going to get the right answer. Okay. However, I'm going to copy this real quick. Same thing applies here. What if this was not A and B? Actually, you know what? Now that I think about it, because I don't really care. I can go through it later on. For right now, I don't really care. I can run these statements. Actually, you know what? Let's keep it with the print statement to avoid any errors. Okay. Okay. So not A or B. Okay. What is this going to yield?
Not A and not B.
Exactly. Not A and not B. So a little Python came out of there. So, okay, that is for the ands and the ors. Now let's continue on. What if this was not A equal to B? Not A equal to B. Now, there's two ways that you can write this, okay? Then again, this goes down to a preference. You can say not A, not equal to not B, or A not equal to B. Okay, either one works. And finally, A, oops, yeah, oops, sorry. Oh, A not equal. What do you think this one's going to be?
Either not A equals not B, or A equals B.
Bingo. So it's going to be not A equals not B, or A equals B. Okay. And again, I put true for A and B and true for B. Doesn't matter what A and B are. Okay. It really does not matter. And the reason why I say that is because if you don't know how to break these down, you're going to get the wrong answer. The important part is understanding how DeMorgans Law applies. Okay, the way that the distributive property is applied to these to simplify them, to get them out of the parentheses. Okay, now this is just for Booleans. All right, now let's move on to actual numerical equations. Okay, so let's say we're dealing with numbers. Or inequalities or logical expressions, just to cover all my bases. I almost put espressos. I'm funny. Okay, so let's take a look at this. All right, let's say not A is greater than B. Okay, not A is greater than B. Okay, now the way that we can say that, now in this case, actually, you know what we'll do? Boolean A, that's fine. We're going to go C and D. Okay, so we're going to work with C and D. Okay, so simple line. Okay, so not C, okay, or D. Who can guess what this would break down to?
Not C is less than not D.
Wrong. The
C.
equivalent to this is going to be C is
Less than
less than or equal to D. C is less than or equal to D. Okay. That being said, let's copy the whole thing. Okay. If I were to say not C is less than D, what do you think it's going to shift to?
C is greater than or equal to D.
Exactly. Hold on one second. I just got a funny note from. Okay. All right. Sorry about that. I got a funny note from Mr. Perry. Sorry about that. Okay. So, okay. Okay. So not C, not equal, or sorry, C is greater than or equal to D. So that being said, now if we flip these around, so let's say we say not C is greater than or equal to D. What do you think this is going to turn into?
C is less than D.
Exactly. Okay. And so we have C is, okay. So if we say C is less than or equal to D, okay, that should mean, go ahead.
C is greater than D.
Okay, great. Okay. So the last two are actually easy. Okay. So let's say I say not C is equal to D. This one's an easy one.
C not equal to D.
Bingo. And then the last one, okay, is C not equal to D. Okay. This would be
C equals D.
okay. So basically what it's doing is it's, you're flipping the expression on its head basically for the most part, with these ones being very similar to your Boolean expressions. Okay. All right. So that being said, let's just do a practice problem. Okay. All right. So I want you to write this out. Okay. Let's say that we had this problem here. Okay, so this is going to be our practice problem 1. Okay. Let's say that I gave you this, not A, or actually, you know what, not C is greater than D, or C not equal, or D, sorry, not equal. Okay. Not C is greater than D, or D is not equal to C. When I break this down, what would this convert to?
Would it be C is less than or equal to D, or D is equal to C?
What is it again?
C is less than or equal to D, or D is equal to, or D is equal to C.
Close.
It's C is less than or equal to D and D is equal to C.
Okay, bingo. The answer is C is less than or equal to D, and you forgot to flip the or. D is equal to C. Okay. How many of you got that? Not too difficult, right? Okay, good. Okay, so practice problem 2. Second. Okay. not C equal to D, or actually, you know what? C, D, okay. So C not equal to D, or C greater than or equal to F, or D is, actually, sorry, D is greater than or equal to F, or D is less than C. Okay. That's good. Okay, take a look at it. Okay, so the first thing I want to do is I want to handle everything out in the external parentheses first. Okay, so I'm going to say C is not equal to D, and okay, and then what I'm going to do is I'm going to apply the not to this equation here. Okay. So now that I've done that, okay, now what I can do is I can then break down this equation. I can say C is not equal to D, and then I apply my rules. Okay, B is less than, I'm sorry, D is less than F, and D is greater than or equal to A. Sorry, C. Yeah.
Mr. Martinez,
Yes.
do you need to keep the parentheses?
Yes, you do need to keep the parentheses. Okay, because after this is broken down now you can run this as a regular PEMDAS equation. Okay. So for example, now that we break this down, okay, what is this going to yield? Knowing that we have 4, 5, and let's say 6. Okay, now that you have this, now that you've broken this down, you can actually plug in the numbers. What is this going to break down to? So first of all, let's do our parentheses first. So 4 and what? Or 5 is 5 less than 6. True. Okay. And is 5 greater than or equal to. So this is false. So what is this going to yield right away? Anytime you know that the right side is false, what happens?
It's going to be false.
Why? What's it called? What's that term called? What's that term called? Who remembers? Who remembers what that term is called? Who remembers? Short circuiting. Okay. Oh, it's not, I'm sorry, I misread it. D is greater than or equal to, yes, C. So this is actually, I take it back. This is true. I don't know why I read this as equals. This is, so this portion is true. And is C not equal to D? True. So it's true and true, that equals true. Sorry about that. I don't know why. For some reason, I just had a brain fart. I saw it as that. And you know me, my brain doesn't fart often. Okay, so this is DeMorgans Law, okay? This will be an actual really helpful video, okay? Because you are at least going to have 2 questions on DeMorgans Law, just specifically asking, like, do you know what is going to be spit out? Now, hopefully you guys can understand why it makes sense that I didn't even care what A was or B was, okay? Because what I want you to do is learn how to break down these equations. Okay, and is there more advanced things that you can do when we get into hash sets with DeMorgans Law? Yes, we're not getting into that. Okay, that's A and B. We're not equipped for it, et cetera, et cetera. It's better if we're learning that with robotics, but unfortunately, it's kind of hard to teach you guys robotics. It's only so powerful if I show you the robot. You know, it'd be nicer if you're actually working on it. Okay. So, but that being said, does anybody have any questions about DeMorgans Law? Now, honestly, did we really learn any code here? We learned principles. Okay. We learned rules. These are rules that you can put on flashcards. Okay. And just study and practice them or make a freaking Quizlet out of. Yes, Will.
It's like the practical use of using this.
It's literally just to throw you off.
Okay.
It's
So,
just,
like, you don't use it.
this is like, for example, 7 out of the 13 courses you'll take in computer science in college are theoretical. They will never really happen in the real world. Okay. They're like what I like to call Benny Eisner classes. Okay. They'll ask about things and they'll go over things that nobody ever really thinks about or will ever do in the real world. But he's inquisitive enough to know and ask about them. So kudos to him, but no one else really cares. So
Then why do they teach it in the first place then?
you should know because it does help when you're like for error analysis. Like, for example, if you know something logically can't happen, it's almost like teaching you computer logic. It's so you can avoid things like that. Like, for example, in standard computer programming, your program will just crash. In mechanical engineering and assembly language programming, yeah, wrong move could kill someone. So it's more understanding that theory about what something is, understanding the math and understanding the limitations of what a program can do and what they can't do. But also when you get into that, you're also talking about memory and you're talking about power. So that's more when you get into advanced comp sci classes, you'll learn about power distribution and things like that. And again, like, for what we're doing, your computer Eclipse might crash. You are doing assembly language programming. You make the mistakes because you don't know the limitations. You don't know the theory behind certain things. You already don't have a knowledge of what's possible and not possible. You could kill someone. Look at Chernobyl. Perfect example. Okay. So, all right. Any questions? I love ending my day on a happy note of Chernobyl. I can't believe I just did that. All right. Nuclear explosions, everyone. Okay. So I'm going to post your homework online. Okay. It's going to be a DeMorgans Law. It's going to be the chapter in the book. Okay. Yes. Thanianos.
Can I ask you a question after class?
Does it involve questioning?
Yes.
Okay. All right. Everybody else, you're good to go. Good class today. Quizzes. Nobody got a perfect score. A lot of people missed